All right, let's dive into one of the absolute best chapters for your board exams, matrices. Seriously, this is one of the easiest, highest scoring topics out there. It's where you can pretty much guarantee yourself some solid marks. So, let's get you prepped.
Look, I get it. Exam season is intense. You've got so much on your plate, especially with that constant pressure to hit those minimum percentage requirements. It can feel like a lot to handle.
But here's the good news. This chapter is your friend. It's your secret weapon, honestly. By the time we're done here, you'll have a rock-solid grasp on every key concept, and you'll be ready to nail any question they throw at you. Okay, let's start at square one. Before we can do any of the cool stuff, we have to answer that big, basic question. What even is a matrix? It's really simple. A matrix is just a box of numbers, or rectangular grid. The key thing to get is that it doesn't have a single value, like a 5 or a 10. It's purely a way to keep information neat and tidy. And that organization is all about two things. Its horizontal rows and its vertical columns. So the size of that grid is called its order, and we write it as m by n. M is always the number of rows, the flat ones, and n is the number of columns, the tall ones. And if you want to find any specific number inside, well, it has an address, Aij. The I tells you which row to look in, and the J tells you which column. It's just like finding a seat in a movie theater. Row I, seat J. Okay, pop quiz. This is a classic one-mark question you will almost definitely see. If I tell you a matrix has 36 elements inside it, how many different rectangular shapes, or orders, can you make? Take a second. This is just a fancy way of asking, what are all the pairs of natural numbers that multiply to 36? And the answer is 9. Now here's the trick they're testing you on. A 1 by 36 matrix, which is one super long row, is a completely different order from a 36 by 1 matrix, which is one super tall column. You have to count both of them. Once you do that for all the pairs, you get a total of 9 possible orders. Easy mark, right? All right, now that we know what a matrix is, let's meet the family. Think of this as a tour of all the different characters in the matrix world, because each one has its own special name and purpose. Okay, let's do a quick roll call. A row matrix? Yep, just one row. A column matrix? You guessed it, just one column. A null or zero matrix? It's filled with, you guessed it, zeros. But the most important one, the absolute star of the show, is the square matrix. That's where the number of rows equals the number of columns. This guy is the foundation for almost everything else. Now, within square matrices, there are a few special types, and they build on each other. So on the left, you have a diagonal matrix. The only non-zero numbers are on that main diagonal line. Okay, simple enough. Now, a scalar matrix is a type of diagonal matrix, but here, all the diagonal elements are the same number. And finally, the identity matrix is an even more specific type of scalar matrix, where all those diagonal elements have to be the number 1. See how it gets more and more specific. All right, let's talk about some basic math. These are the easy wins, the simple operations that are going to build your confidence and rack up some guaranteed points on the exam. Honestly, there are just 3 rules you need to know. First, for adding or subtracting, there's one non-negotiable rule. The matrices must have the exact same order. Same shape, period. If they do, you just add or subtract the numbers in the matching spots. Second, scalar multiplication is just multiplying the whole matrix by one number on the outside. That number just gets multiplied with every single element inside. And finally, for 2 matrices to be equal, they need the same order, and all their corresponding elements must be identical. That's it. Okay, it's time for the main event, multiplication. Now, this is the one place people sometimes get tripped up, but it's actually not that hard if you just break it down into 2 simple questions. When can you even do it, and how do you do it? So, first question, when is it even possible? The rule is super simple. You write the orders next to each other, and you look at the 2 numbers on the inside. If those inner dimensions match, you're good to go. But if they don't, like on the right, multiplication is impossible. You just can't do it. It's the first check you should always make. And now for the how. It's a simple little dance, row by column. So let's say we want to find the element in the very top left of our new answer matrix. You take the first row from the first matrix and the first column from the second matrix. Then you multiply the matching elements together and add up the results. That's it. You just repeat that row by column process for every single spot in your answer. Okay, we've got the basic operations down. Now let's get into some of the more unique, let's call them personality traits, that some square matrices have. These properties are going to be crucial for solving the tougher problems. First up is the transpose. It sounds fancy, but it's so easy. All you do is flip the matrix along its main diagonal. The first row becomes the first column, the second row becomes the second column, and so on. This super simple idea is the key to understanding the next two types. So a matrix is called symmetric if you take its transpose and you get the exact same matrix back. It's perfect.